these fatigue fast. And there's, you can take a physiology class and go into more depth on this, and I cover it more in physiological ecology. But these fish, these fibers, are operating anaerobically. That is producing our lactate or lactic acid, which accumulates in the cells, and that's what causes fatigue. You have to get rid of that lactic acid that is accumulating, and that takes a certain amount of time. If you operate aerobically, you are not accumulating lactic acid, so your muscle fibers would be slow to fatigue because they're not accumulating that lactate. Okay, so our red fibers are adopted for slow, continual motion with high efficiency. In other words, we're using aerobic processes and getting lots of ATPs. Right? Slow, continual operation with high efficiency. The white, though, is used for bursts of activity. Right? So when you want to go from 0 to your top speed, you're going to be using anaerobic processes because you get those ATPs very, very rapidly. The penalty is that you accumulate lactate and it's not very efficient. But you can go from 0 to top speed very fast. Right? So the white is adapted to giving you these bursts of activity. You burn a lot of glucose, it's very inefficient, you produce lactate. But you can go to high speed very fast. Right? You can go to your high speed, but you can't last long because of the lactate. So, 85% of our fish fibers are white. That means that they are carrying around 85% really of their bulk is used only for burst activity. The other 15% is what they would be using for slow, continual motion. So, if they're only using this periodically, how can they get away with carrying around all of that bulk to only use it every now and then?
If it saves your life in case of a predator, then it's worth carrying around the bulk.
True, but there is a physical reason that they can get away with it. That's a very good biological reason, and you would expect that from natural selection. Less mass, less bulk? No. Okay, because the mass of the white is going to be the same as the mass of the red.
The medium is different, moving through water as opposed to on land.
And we're getting there.
Less
Gravity.
gravity.
Okay, so a fish is somewhat buoyant in the water. It is buoyed up by the water. Whereas if you come out onto the land, you don't have the air holding you up anymore. So the fight against gravity, carrying around the extra weight, is not that much of a problem because most of the time you're neutrally buoyant. You're not being pulled down to the ocean. As soon as you come on land, you can't do anything unless you hold yourself up. When you walk around, everything has to take energy in order to do that. If you're a fish in the water, you're buoyed up to a large degree. So you can get away with carrying around a large portion of your body mass for infrequent use simply because it's not costing you a lot of energy in order to do so. But that is a good selective reason as well. You got to get away. Or if you're the predator, you got to be able to go at top speed in order to get your food. All right, so just a prediction. If you have a tuna continually moving at high speed most of the time, what's the relative proportion of the red? Is it going to be a high or low in that animal? Red fibers. High, okay, because it's continually moving. And so it wants to have that slow to fatigue. You have a catfish. Catfish is a bottom dweller. It just hangs out. Every now and then it might have to move fast in order to escape a predator. Is it going to have a high or low proportion of red?
Low.
Yeah, it's going to be low. right? And you can, there are a lot of examples like that you can make. The lifestyle of the fish does affect the amount of the red and the white fibers that it has. Okay.
So then sharks would have more of a red portion because they're continuously moving?
Yes. And I had a diagram, I thought. Maybe I shouldn't think. Can't find it. Oh well.
You mean the one on the
Well, we could go to 11. 11 is a table that lists these differences between the slow and the fast fibers, between the red and the white fibers, so that potentially can help you. Oh yes, that is 11. So at the top, that's what I was looking for. On the left of those drawings is the cross section of a fish. So the black in the middle is the vertebrae, and the light stippling are the white muscle fibers. The red is the darker stippling. You can see that it's located around the outside, and it is a very small proportion of that fish compared to the white muscle fibers. So that's what I wanted to get across. Any questions? Yeah.
So just to understand the picture better, it's those two circles on the side, and the red portion should be like the outside. It's all gray on ours. Okay, so not the middle.
Well, yes, yeah, but the darker stippling on the sides
on the
of
sides
the
is
animal
the
is the red.
Okay.
And the bulk of that cross section is the white. Great. All right, we're gonna start amphibians in lab. So I'm gonna tell you one extra thing that we're going to do this time. I think you guys are catching on because the grades were very good on the lab practice. We're going to start amphibians. We will begin today looking at orders and families worldwide. I think there's 15 different families that are out there. And then next time I'm going to bring in Michigan species. And so we're going to have to start learning the scientific names of and how to identify Michigan species of amphibians. And I will email you some frog and toad calls that you are going to be responsible for on the lab practical. So when you come in at the lab practical, I will have a tape recorder or a CD or something, and I will play four frog or toad calls, and you're going to have to tell me what species they are. Right? Okay. If you noticed on the syllabus, it mentioned taxonomic keys, and there were a certain number of points for creating a taxonomic key. And so I'm going to illustrate that here, and I'm going to ask you to make a dichotomous taxonomic key for these 15 families of amphibians. So the words I used. Now most of you, have you used, who has used a taxonomic key at some point? Okay, then this will be easy way of getting some points. A key is just an artificial way of determining the identification of an unknown object. And you can have keys to rocks and minerals. You can have keys to twigs. You can have keys to fish, invertebrates, anything. You can make a key. Taxonomic is up there because it's going to give us the name, the classification of the animal. Dichotomous are the best keys, the simplest to use, and dichotomous means that you're always presented with two choices. So, I'm going to create a taxonomic key using Ashley, Emily, Joshua, and Catherine. Oh, but I just saw a problem.